I think we're live now, so I'm just gonna wait for the YouTube notification as as always. And let's see what we're gonna do here today. That has to change for sure. I think we're finally live. Let me just do the audio checks as usual. Did I hear myself? I think we're finally live. There you go. Yeah, you guys let me know if the audio is good. If the audio is shit. You tell me. But anyway, welcome everyone. It's good to see some of you already like waiting for the stream, which is really good. And I can't wait to do some C++ here with you guys. There will be some CMake work. There will be some refactoring work. But hopefully by the end of all of this, we will be able to have an ECS in the rendering engine, right? But yeah, I'm gonna start this. So wait, what's CMake automatic? Hello Slim, how's it going, dude? It's good to catch you here from the start. I have no idea what these things are. Auto MOC, Auto UI. Anyway, so the sponsor of today's video is Slush Puppy, as you can see here. And it tastes horrible, by the way. That's what you can get for 60p in a corner shop here in the UK. 500 milligrams or milliliters of pure pain. But yeah. So, what did I change from last time? So I did do some work over the weekend on the ECS stuff. Just because I realized that having the ECS as a C++ module makes it very, very difficult for me to then include in a rendering engine that I actually want people to use. And the reason is, well, not everyone is going to be using C++ 23 and having the latest and greatest compilers, right? So it makes it very, very difficult. So my changes were mainly turning or reverting that module architecture into just headers and C++ files. At the end of the day, this is basically just a header-only stuff now. Hello, Muslight. What's up, dude? It's good to see you guys here again. I'm Robin. Robin F. me. Robin F. Namey. DX and hi. Hello, dude. Yeah, it's still here. I think this is still here from... I can't even remember how long ago we started this ECS thing. Maybe like 2 months ago. I haven't been as active as I'd like to be. But we're using it now, so we have to actually make it work. But yeah, so the first thing I'm going to do is make sure that I can actually include this into a project here with fetch content, right? So I'm just going to copy the latest shard that I've got, and then we can see if it actually works now. How do I copy the whole thing? There you go. So commit and copy shard. Git tag there, and let's see if it works. But how have you guys been? It's been a very busy week here for me. That's why I haven't really done any streaming. But I'm excited to hear about your guys' week and your weekend as well, right? Because we're nearly in a new weekend now. It's Thursday already, I know. But I haven't really spoken to you guys since last week. Right, so this doesn't work. And why is that? Performing update, step for ECS populate. Previous added position. Okay, merge conflict. Okay, yeah, so we just basically have to nuke this directory here because it's trying to merge things with Git. Let's do a reconfigure. Started working on a new portfolio kind of site this week. That's nice, Robin. And Robin, I might actually get in touch with you because you do front-end stuff, right? So you are very good at doing front-end things that look good. I actually have a family business website. So it's a business for my auntie, and I'd like to spend some money on it to actually make it look better. So if you do have like time at some point, let's chat, because I would rather hire you than someone random on Fiverr, to be honest. Muslight, it's been an interesting week for me. I changed my programming path from C++ Python to web dev. Oh, you changed it completely, dude. Oh no. It's a shame to see that you've moved away from C++, but it's understandable, right? It's easier to find a job in web development for sure than it is in C++, at least when you start. So yeah, I Yeah, I mean, it hurts me that you've moved away from C++, but at the same time, I'm happy that you've realized that you probably want to actually get on the job a lot quicker, right? So yeah, web dev does help you in that sense. You can hit me up anytime on Discord. Thank you, Robin. I will do, man. I'm just like waiting to have that weekend where I'm actually free to start working on these things, and now I actually will. Because yeah, very very few weekends, in the very immediate weekends that we've had, I've not had any time at all. Just been doing random stuff, random live stuff. But yeah. So what do we have here now? So did it actually work? No, it didn't. So let's see why. CMake error, build ECS app. Cannot find source file, compile time.hpp. Okay, so this might be something that I actually forgot to push. So let's take a look at that real quick. So it says that we're missing compile time.hpp. So let's see why that is the case. By the way, I have a demo of a new site. You want to take a look? Yes, dude. Yes, post me on Discord. I'll open Discord here, and we can collectively judge Robin's website. But I'll tell you what, guys, they're usually really really good. Hello, Vlad. Hello, Vlad Antoni UK. How's it going, dude? It's the second or third time I'm seeing you here, so welcome to the stream again, and it's very good to see you, man. So let's take a look at Robin's new website. This is it. It's safe for work, right? I've not actually checked before, Robin, so I'm just opening this. Thanks for visiting. I like this. I like this little like notepad thing. Can you type on it? Nice. I'm a software engineer with a passion for building things. I have experience with a variety of technologies and programming languages, and I'm always looking to learn more. That sounds about right. Yeah. Using the dock at the bottom of the screen, you can open different applications that showcase my work. Feel free to explore and reach out if you have any questions or would like to work together. Also, there may be some hidden Easter eggs. Let me see if I can find them, shall we? So, I like that. I really like this, dude. Let's see the terminal first. Okay, so Echo is not supported at the very least. Oh, CD home takes it to Jonathan. What do we actually support here, though? Yeah, just CD clear and whatever. There is no Easter eggs yet. That's all right. The terminal is not done. That's okay. Robin, I have like an amazing video recommendation for you. I think there was this like interview question that I once did here on the channel. It was like writing a REPL, right? So writing something that interprets commands written from a user. So you might find that helpful because you might be able to implement that in like JavaScript or something, right? It's very easy though. It's not difficult at all. But yeah, that is cool. So these are all your websites from the looks of it. Is that correct? This is really nice, dude. I like that. Can I resize it? Nice. I can resize the inner window. So how is all of this done? Are you like just using some sort of framework to like render within the website? Because I guess you're drawing on the canvas of, oh, it's an iframe. This is an iframe. Oh, never mind then. It's just an iframe. That is cool. Next.js. Ah, right. I've never used Next.js. I know it's good, but oh, there's a little game. That's sick. Okay, it's just Minesweeper. 2, 3, 1. Yeah. Okay, cool. That is definitely cool. There's one here. I like that. I like that, dude. It looks amazing. Well done, Robin. Yeah, if you guys ever need someone to, to do your front end of your website, Robin is a very good web designer. So he's the man to go to. Right now, let's check this issue with the missing compile time HPP, right? So let's take a look at this. Matt, are you in embedded systems? I have been, yeah. I've been an embedded engineer for 2 years, dude. I worked for a company called Jaguar Land Rover. I'm not sure if you know them. They do cars. But there's still software that I wrote that still runs on like Defenders and stuff. Why the question? Do you need any help? Can I help you with anything? Let me know. So this says that we're missing compile time.h, right? Yeah, we are missing that. So git add compile time include. Let's just add that file real quick. Let's push this. And that means we have to actually get a new SHA now here. So we can get that new version. By the way, I know this is one like little advice that I've got for you guys if you're doing C++. On the channel, if you follow if you follow the channel quite a lot here, you may have seen me talking about like Conan and VC packages, package managers. But when you have something just as basic as this, where you just want to include like someone's CMake project into your project and use the targets, you can just do it with fetch content, by the way. I don't mention this nearly enough, nearly as it should. But it's a very easy way for you to just kind of get CMake to pull the project from a Git repository or a URL and just build it as part of your project. So yeah. So Robin, I'm not a bad C++ dev, and I've developed a few front-end apps with PyBind and etc. I decided to go on with web dev. Any recommendations? Oh yeah, that's a question for Robin. I'll let him reply to you. So now, see, we actually are able to include ECS there, which is good. So let's just build it and see if it actually builds. I suspect we might have to bump the version of C++ here. I'm not entirely sure what version we're using for the ECS project, but yeah. Hello, Brock Daniel. It's an old school name I like to see here. So can I open include file ECS? No such file or directory. Interesting, isn't it? Like, why? So the build fails on the ECS again. We can try and like get it through this. Let me remove this goddamn heart symbol here because I can never see the messages that go over it. So let's hide the element. I feel like a hacker every time I do this. What are we gonna do today, Matt? What's the plan? So the plan is to actually incorporate the ECS and what we have now here, right? Let me just explain it to you guys real quick. On the renderer class, I think we have like a mesh array, right? So we have these mesh arrays here, which just stores everything that you want to render, so like all the meshes, which currently we just do a cube, right? That's what the application does. But the idea is to turn this into a system. So instead of storing the meshes here, we just have a reference to the registry, so the ECS registry, and we can query the meshes from there. Like we can query all the meshes that we have in the ECS and render all of them, right? That's what we're going to do here today. Or try to anyway, because it might be a little bit long. But the first thing that I'm kind of failing to get is the ECS actually included or integrated in my render engine, right? Because we do have a basic ECS. Now we just want to include it. Okay, so let's keep going at it. So main.c++ is failing to actually include ECS. So private main ECS. What happens if I change that? That's the question. Yeah, for some reason the missing target here is, well, it's not appearing. So this is what we should be including: MAECS alias to MCS. So we do have an include here, cascading publicly. So I don't see why that's not working though. Yeah, still not working. Which is definitely weird. Why is this not showing up? Is the include directory name wrong? ECS. Oh yeah, we don't actually have the file. Like, what? The file actually isn't there. And again, this is just something else that I forgot to push probably. So yeah, there you go. So let's do a git add. We're gonna add the file ECS 267 there. This is yet another missing header file pushed. Okay, same thing again. We're gonna just kind of remove all of this, delete, and we are gonna get a new SHA. So I was asking out of curiosity. I just finished a game engineering program in college, and looking to land a first programming job in games, but the market is in shambles. Yeah, Vlad. So I'm taking that you're probably in America, right, or something. And it is, man. I mean, the job industry, the computer science industry now is not on its high peak. Let's say it's kind of yeah, people are struggling to find jobs at the moment. But what I will say is that, you know, I do strongly believe that in the next few months, maybe, you know, 3-4 months, 5 months pushing it, things will get better because the interest rates are coming down, which means like companies will start like investing again. And hopefully this translates to more jobs in the industry. But yeah, it's very difficult, dude. And you just got to keep trying. If you don't mind working somewhere outside the gaming industry, that could be an option as well. Like the game industry is notoriously hard to get into, if I'm honest. And in times like this, where it's even harder to find, you know, other jobs, it's even harder to get a gaming job, basically. But it's up to you, man. If you want to keep like applying for gaming industries, go for it. Nothing against that. It might just be a little bit more difficult than applying to other industries as well. No problem if you have other questions. Okay, that's probably no. I'll let you guys have the conversations there. Right, so let's see now. Now with the missing header, things should work a little bit better. So let's build it. So now we should see in the source. Oh no, we still don't have that. Oh no, yeah, we do. It's here. So the missing header is here now. We've pushed out. We should be able to use the ECS hopefully. Let's build it. Yeah, what's interesting about, you know, while this is building, what's interesting about the fetch content declare way of doing things in CMake is that it literally will just copy and paste the entire CMake project into your project. So it will build everything that builds on default on that project. So you can see that it's building like the tests and the end-to-end tests and whatnot. It's just, you know, something that that's going to happen when you do fetch content. Are there any alternatives to look for? I learned C++. I learned ++ mostly. Is that meant to C++? Is that meant to be C++? I learned C++ mostly related to graphics engine dev. So you're actually in a good situation, Vlad, because, you know, graphics and game development are very kind of difficult concepts to understand. So I would say that you can probably just switch into anything, dude. Like C++ is C++, right? Whether you go from graphics or gaming to, you know, embedded systems, to writing kind of cloud applications, to software, to desktop applications, it's all the same. It's all a language. So as long as you know the language, you should be able to like switch between areas. Obviously, if you go into somewhere like, you know, gaming, you have to know a little bit of graphics. You have to know how things work in general. You probably need to know a little bit of OpenGL, Vulkan, or even the game engines themselves. But that is knowledge that you can acquire either at the job or as you practice for the interviews, to be honest. And you really only get experience for those kind of, what's the word? You only really get the specific experience once you're doing work in that. So a good example is when I was a Jaguar Land Rover, I worked a lot with different protocols for data transfer. So like HTTP, MQTT, and a bunch of others. I didn't really know anything before starting the project, but by the end of it, like I had done so much of it, I had read so much of it that I was just good at it. So, you know, companies should really be looking for people who are good at problem solving in general and know, the main language. Aside from that, you can kind of learn the specifics on the job. So I don't think it's going to be hard for you to switch into anything you want, dude. I'm going to use Qt editor instead of IMGUI or just for window. So I don't know yet if we're going to use Qt. At the moment, it's just Qt. I'm not using the editor yet because I haven't really got to do any web development, but I might just do like a GW or GLFW window management system thing with IMGUI. Just, this is supposed to be something for people to demo code. So yeah. What do you prefer between you recommend fetch content, Conan, or VC package, or even submodules? I do not recommend submodules for once. I think they're a very, very messy way of doing things. Fetch content is good for when you just have like one or two dependencies that have an okay-ish like default CMake build process, because some dependencies, like, they will create so many targets, they will create things that will clash with your program. And when it comes to fetch content, as I said, it just copies and pastes the dependencies, which means if you have like an install target that has the same name as a target in your program, it won't work. You have to patch it. So it becomes less good for that. Now, if you are doing a lot of dependency management, so if you have like, let's say 10 dependencies, and you have a very specific build system where you have your own compile flags, you're building for perhaps different platforms, right? Not just one of them. And yeah, you want to do versioning a little bit better, then Conan and VC package are for you, dude, because those package managers will kind of isolate the builds for each dependency, so it doesn't interact or interfere with your build at all, which is not the case with fetch content declare. And they just give you like better control of the build. So yeah, it depends. Yeah, the answer is it depends. For anything simple, fetch content is fine. If you need something more complicated, then go for the package management stuff. So yeah, I hope that answered your question, Pedro. And welcome to the stream, by the way. Right, so what are we getting here? So we did not build. And this is probably because we have some sort of like flags that are let me just look at this. See, like, we already have one of those problems with that I mentioned with fetch content declare. The build for the ECS stuff just succeeds on my other project because I have different flags, I have different warning levels. In here, this is a problem. So result of 32-bit shift implicitly converted to 64 bits. So yeah, unsigned LL. So this should have been unsigned LL here, right? Which is okay. I mean, I'm gonna have to put a fix on this, which is annoying, but if I just build it now, let's see what happens. Cool, I like Conan and VC package, but everyone has them installed, configured. It seems the only truly easy way to build for anyone are submodules or packaging. Yeah, that is the problem with package managers, right? So once you go over to something like Conan and VC package, you're expecting the user to also have that installed. So that's maybe why you want to consider just having a fetch content declared, because you can guarantee that they have CMake. But yeah. So what is this now? So this is supposed to be a size T, and again, this is supposed to be URL. See, just one of the problems that we were just mentioning. I think Conan is the best option, but sometimes I can't find not very popular libs. I agree with that. I think Conan is also the best option in terms of giving you control of the build. But yeah, sometimes you're not going to find the library that you want in the Conan repository. This is why you guys should learn how to write recipes yourself, so you can go and contribute it. But yeah. To be fair, I haven't really used VC package in a long time, so I don't really know like what the state of the project is at the moment. When I used it back maybe a year ago last time, maybe 8-9 months ago, it was a lot better than the even previous version of it. So error, the following is treated as an error. What is this? The following is treated as an error. Entity view, local variable is initialized but not referenced. See, another kind of issue with the way I'm doing things here. I would like to contribute to SOAPy SDR to Conan when I have some time. SOAPy SDR. I've heard of that. What is it? While it's building. SOAPy SDR. Vendor and platform neutral SDR library. What is an SDR support library? What is SDR? I've heard this name before, but it's gone off my mind now. SDR. It's definitely not what the first thing says there. Oh, it's a radio thing. Yeah, that's why I've heard of it. It must have been in your video. I would like to. I hate VC package because it wants the version of the current VC package. It wants the version of the current VC package version on the file. What a joke. Does it? I can't remember that now, but yeah. If it does, that sucks, yeah. Right, one by one we're getting rid of these issues. So we still failed here. The following is treated as an error. Unreferenced formal parameter. Again, we haven't referenced this. Create entity with component. How the hell has this been used? Create entity with component. It's in the benchmark thing. Huh. I do wonder if we can just comment this out. This is just code that was meant to be commented out, but obviously haven't or hasn't. Let's just rebuild that without this. A lot of warnings though, I can see. Yeah, this project has a bunch of flags enabled, and it's also using the. That's the thing, you know, whether you compile on Linux or Windows makes a difference to the warnings that you get, because MSVC has different warnings compared to GCC and Clang, and this is one of the problems I'm getting here. Most like, yeah, managing versions is kind of shit in VC package. Yeah, I 100% agree with that. Especially they have like the baseline. I think it was called the baseline version, where you have to like provide a commit hash to the VC package repository where you want to get your dependencies from. So all the yeah, it's very it used to be very difficult to work out what you actually need in there. And I think I did explain in one of the videos that I made about VC package, but I need to watch that video again because I already forgot. It's not as easy as just having a major, minor, and min version that will get overridden. It depends on the temporal state of the VC package repository, like in terms of what you get in the end, what version of a library you get in the end. And that was extremely difficult for me to to understand, to be honest. But so error, the following is treated as an error. So this is also right. All of this stuff is basically not mentioned anywhere. So let's just kind of comment them out. Okay. I like that it's not running on a whole other language though. Yeah, that's the good thing about VC package, because yeah, as you know, Conan is entirely written in Python. So as well as having CMake installed, having compilers installed, you also need Python to Conan, which is not ideal. But in CMake you don't get that. So okay, let's just comment this out here. I keep getting different errors every time. What the hell? What is the issue now? So, what is the problem? The following is treated as an error. Did I just not save the file? Let's build it again. Yeah, one of the things that I miss from Rust is definitely having the package manager part of the language. Having cargo there is amazing. So if you guys, I recommend you guys try and Rust at some point to see if you'd like it. My position. See, none of these things are being mentioned anywhere. So I'm just going to comment them out. I'll sort this end-to-end test out later. This is basically just like a little end-to-end test in the ECS project where I'm just drawing some of the... there you go. So now we finally build, which means that, yeah, we're able to use the ECS project inside the system, right? So let's actually do what we're meant to do in this video, which is taking a look at the renderer class, right? So we have a renderer class that basically abstracts a whole OpenGL, the whole OpenGL idea of rendering something, right? So it will have references to the shaders that it's using. It will have references to the attribute vertex object or vertex attribute object. I think that's the right one, where it stores like basically, a state of which buffers is going to be looking at and so on and so forth. And it also currently stores the references to or the mesh object that it wants to draw. So that's what we're going to be changing there. The third point, which is we're not going to store the meshes anymore. So that is just going to be in one place, which is the ECS, right? So that's what we're going to do here. And I'm not sure if this is going to work, to be honest, because I'll be honest, I've only tested the ECS with very basic types, like creating sort of structs of integers or something like that. And I have no idea what will happen when I actually put more difficult types. Like I start putting containers into the component, and yeah, it's going to be interesting to see. Like it's definitely not going to be anything performant, but yeah. So if you do class renderer here, yeah, this is the class that does all the rendering, right? So we have renderer, and here, this is the thing that we're going to delete. So I'm just going to comment it out for now. I'm going to build it and see where I'm going to use, where that's getting used, so we can pass in the reference to the ECS instead. Now, I think that the ECS should really be stored in a shared pointer or something, right? Because if we think about it, we definitely don't want to copy it around in different places. We don't want to have a reference to a stack variable either. Say we were to create the registry from the main function. I mean, that could happen. But yeah, let's see what actually happens here. So I think it has to be a shared pointer just because we want it to live. This is not going to be the only place where we're referencing the same registry, right? So what I'm saying is like we do something like stud shared pointer to a ECS registry, I think it is. So we have the ECS here, or the registry. And of course we have to actually get to use, what the hell am I doing? So this is a third party dependency, so it'll be somewhere like in here, right? So we have ECS, and then we have ECS. Ooh, I can't spell today for some reason. ECS.hpp. And because we're adding the ECS here, we also have to slightly change the CMake list so we can have a reference to the ECS here, right? So ECS. Perhaps I don't think this has to be a public thing because we're going to forward declare it, right? So do you guys know what forward declaration is in C++ and why it's used? And if you don't, let me know because I can explain to you. But yeah, we're going to forward declare it, and we're not actually going to cascade a dependency down. So this could be a private, just private here. So ECS. Okay. Can you talk a bit more about that? I always struggle with stack versus heap allocation beyond just new delete. Like if your ECS has stack variables, but you make the ECS a pointer, what would happen? So let's actually, yeah, I can explain that a little bit, I guess. So I'm guessing that you know what what the memory looks like, right? So every program has a virtual memory, and let's say it was, what? Why is my Excalibur not working? There you go. What I wanted to do is like draw some tables here, right? So we're just gonna copy and paste this a few times. Just so I can point out what the memory looks like. I'm gonna move these a little bit. I think the diagram might make it worth it, but let's see. If it takes too long, we'll start explaining anyway. Surprisingly enough, I do have a video somewhere talking about this. But this is what your memory looks like, right? So this is like offset 0 right here. And this is, the start of your virtual memory. Draw an 8-bit memory diagram, basically, yeah. So, and this will contain some sort of like 8-bit data, right? So it should be like 0x, FA or something like that. And that's your memory at 0, right? So this is memory 0 here. So, spoilers, I'm actually making or creating a video about this. I've already recorded a video about pointers, but it will be out maybe tomorrow or the day after. But this is your memory address, your virtual memory address, which basically resides on the memory or the RAM memory of your machine, right? And your whole program is actually loaded into this virtual memory somewhere as well. So it will be, let's say, this. Now we're gonna do your program data. So let's say it starts here, right? So that's your program data here. Your program. And you have like a bunch of instructions which are just 8-bit integers. So not 8-bit necessarily. This will be, probably like 64-bit instructions if you're on a 64-bit machine, and so on and so forth. But it does definitely look something like this, right? This is your entire program loaded somewhere in memory. Now, when you do variables on the stack, say this here was your, the start of your function, right? When you allocate memory on the stack, like a normal variable, right? That memory is going to be allocated somewhere closer, or somewhere close to where you're creating that variable, or where you're calling that function, right? So it's going to be somewhere in the function in here somewhere, right? So that's what a stack variable, or that's what the stack does. It just allocates memory very close to the calling code, and all the memory that you allocate is, basically accessible very, very fast because it's the stack. When you do a heap allocation, doesn't necessarily mean it's a heap structure. In fact, I don't think it is a heap structure at all. If you've done that somewhere at university, your program, wherever you're calling that new code, is going to allocate some random memory somewhere in the virtual memory, and that's not necessarily going to be close to where the calling code is. So you might have to do like a very big jump to get to that memory, right? So this is your new variable is going to be here somewhere, and it's an integer, so it's going to have like 4 values, right? So this is what a 32-bit integer looks like, and this is it. This is the difference between stack and heap. Basically, it's like basically the location. That's the only difference. The location at where the variable data is located, right? So when you do a simple stack allocation by just creating a variable in a function, this is the kind of stuff you get. Your data will kind of be very close to where the function is. When you do a new allocation, it's kind of far, and you obviously, as you said, you can have performance issues. So for example, if you're having to do like massive jumps to retrieve that data, things will obviously run slower, right? Now that doesn't mean that my ECS will be slower because I'm storing the registry in a, if I store my registry in a in the heap, because at the end of the day, when I want to use the registry, I have to actually basically dereference a pointer, right? That's what we're doing here. We have say this is my registry here. So I basically have a pointer to my registry. So when I want to access a particular component data, so I want to get all the entities for a component, I'm going to have to call a function on this structure here that will get me all of the entity data, right? So the process of dereferencing that pointer will have to do the big jump, right? So I will have to find out where my data is, and I'm going to have to kind of, interpret this as it's my registry. That will have a big jump, and yeah, if you're doing that over and over again in a very tight loop, it can have performance, performance disadvantages here. But I'm only doing that once, because when I get the data eventually, when I say something like, get all my component data, that function is going to be returning the pointers, shall we say, to where my data is, which might be like these locations here, right? So, and at that point, it's just as fast as if I'm doing it on the stack, to be honest. So it's, yeah. Let me know if that made sense. It kind of made sense in my head. But yeah. What makes DCS fast, however, is making sure that all your component data is going to be stored contiguously. So like things are stored after the other and not fragmented. So what I'm saying is like, I don't want to store some of the components here and then some of the other components elsewhere in the heap and some of the other components elsewhere in the heap. That's what's going to make things very slow. Also, stack is very small compared to the heap, so allocating large objects on the heap would be preferable. Yeah, Vlad's got a point there. So so vector is a very good example. It's probably the simplest example you can have in the C++ language. So when you allocate a vector, the data will actually be allocated with malloc internally, which is on the heap, because you're allocating a very kind of large blob of data, and you can't really do that on the stack because you're going to exhaust the stack size very, very easily, or very, very quickly, shall we say. So yeah, that's another thing between stack and heap. Stack is very limited memory, whereas the heap, you can request fucking gigabytes of data, right? It doesn't make sense. And how do you use the heap? I normally go for the stack, but run into overflow issues. Okay. I've seen many people use unique pointers for almost all members, but they say it isn't good practice. Yeah, so unique pointers for all members isn't good practice. You don't have to store everything in the heap. So the point here is the heap is used for when you need pointers, right? So when you need pointers, you're going to have to do a new call. So like a new object type. That's going to store things in the heap. Now, when do you need that? There are cases where you need that, for sure. So like there are data structures or algorithms that you kind of always need to have a pointer. So for example, I would encourage you to try and implement something like a linked list without pointers. You just can't, because you need the indirection there. There are algorithms that you need it as well. So like sorting algorithms sometimes do pointers. Like tree balancing algorithms need pointers as well. And inherently, that means that your data is going to be mallocked somewhere. When you're doing things like forward declarations, there are design patterns as well, like Pimple, for example. Pimple needs pointers. You need to have data allocated in the heap for that to work. So there are some cases where you genuinely need pointers. But in most cases, dude, if you can just create a variable in your class that is not a pointer, go for that, because it's going to be much better. Because yeah, it does in fact affect performance if you do it. If you're doing a lot of indirection where you don't really need to. So that's the point here. But yeah. So let's get back to this now. Pointers are not necessarily heap objects, though you can have them on the... Yeah, so that's correct. Yeah, let me correct myself. So you can have pointers to stack variables, but when you have data allocated with malloc, which internally is called through malloc, yeah, which internally is called through the new keyword in C++, right? C++ new is equals to C malloc. So when you have data allocated with these things, then it's going to be on the heap, right? Which, you're going to have to keep track of the pointer somehow. But yeah, you're absolutely right, Vlad. You can have pointers to stack variables. If an object allocates stuff on the... Oh. By the way, guys, if you haven't done so, please like the video and subscribe to the channel. It does help me out quite a lot, so thank you very much. If an object allocates stuff on the stack, but you declare instances of the object as pointers... Wait, let's see. If an object allocates stuff on the stack, but you declare instances of the objects as pointers. So if your object has, you know, stack members, but you've created your object in the heap, then that data is going to be in the heap. Yeah. If that's what you mean, then it's going to be in the heap. If your main object is allocated in the heap, but you know, the members are all like normal stack variables, then it's still going to be in the heap, dude. All the data. Because, you know, this is what your class looks like. It's just a blob of data somewhere in the memory. So if you've allocated with new or malloc somehow, then that data for that class entirely is going to be in the heap. Okay. Anyway, so let's actually do what we were meant to. So my ECS here doesn't really work. Can we add that stuff here? Let's try. So my ECS.hpp is actually showing up now, which is good. Yeah, sorry, man. Instances of the class. Thanks. Yeah, no worries, man. Yeah, this is gonna fail for sure because okay, so registry is not a thing. Why is it not a thing? So my ECS, I'm looking at this one here. So my ECS is a namespace, that's correct. But then what is it called? Yeah, it's just registry. So why is it not working? The HPP did add, or did? Ah, okay, yeah. I need an ECS type here. That's for sure. Yeah, yeah. My ECS is a compile time, so I do have to kind of provide all of the types that we're using here. So, what did we have before? Rendered meshes, right? We have rendered mesh there. So let's store that in there. Okay. Now this should build, hopefully. Oh, this file should at least be happy, but the CPP file is definitely not going to be happy because it was referencing the meshes there. Okay, and now this is where we do the magic, right? So we had that function to add mesh. This is not something I want to do in my renderer anymore. So I don't want to add the mesh here. I want to move this to my ECS, or mainly the main calling code of this function, right? So let's do the following. Let's just remove that function call and see where we mess up. Because that's basically where that function should go. So just to summarize this, render is just a very, very simple system that just takes the rendered meshes and then displays them in OpenGL. That's all. Okay, yeah, there you go. So mesh and meshes, no longer have that. So this is obviously has to be using the registry. In fact, we can do that right now, right? So if we have the registry somewhere, yeah, we have the registry here. I believe we have a function called the newest get, I think. Where we have rendered meshes or something. Rendered mesh. Does that work? Yeah, so newest get is there. Oh yeah, this is also a pointer now. See, so it should have been this in the first place. Obviously, before I forget anything, because otherwise we're gonna have a no pointer to the reference here. We need to pass in the shared pointer to my ECS registry in here, right? So this is gonna be rendered mesh. And then, yeah, we have that. Just to make sure we don't break here. Did I add memory? Yeah, I do have memory there. Just want to see if this is going to be happy now. But yeah, if you guys have any other questions regarding C++, do let me know. I'm happy to like go off track and then talk about C++ with you guys. We still got like another hour and a half here, so let's go for it. So mesh is undeclared, yeah, good. But now this should have returned me, I think it's called an optional of entity view vector, right? Yeah. So we have something like alter const maybe entities, and this is actually a vector of a view. Yeah, so it's a vector, is an optional of a vector of an entity view, right? So these entity view things here are basically just pointers again, but to my component data. So they're like pointers that increase by 4 every time, basically. So it's still contiguous in this case. So yeah, let's go back to where we were, because now we have to do, you know, if maybe entities is invalid, right? So if we didn't actually return any entities, we don't have to draw anything. Yeah, we don't have to draw anything at all. Yeah, so in fact, you know, we just put all of these inside the for loop. Let's do that. But we only go into drawing each entity or each mesh if we actually have those entities at hand for us. Okay, so that is that. Now, we're going to have to do some work here, because this is actually, let me remind me of myself what the type is. A vector of entity views, right? So we do something like for auto const, I don't know what the stuff is. I don't know what to call this. We'll find out in a second, which is going to be maybe entities. And this is actually the entity views, right? So entity. Yeah, so for the entity view, we have a function called component where we can actually say, now we want the component for a, what was it called again? Rendered mesh. What will that return me? That returns me a C, right? Yeah, that is good. And this is always going to be something that's valid, because if it's not available in the index here, this line is going to fail for us. So at compile time, we know exactly whether this is going to work or not. So you can see how much more useful this ECS is compared to what we had at the start. Like we can do just something like getting the entity views, and then just actually with a very easy function called component, just convert that to the actual like struct component that we want to call. And this is where we can do the rest of it now, right? So we just basically get all the code that we had before, put it here, and voila, right? That's what we have. Okay, so I think in terms of this code, I think that's it. Now we obviously have to move this function, this add mesh here, somewhere else, right? And also we need to add a stud shared pointer in here, because we forgot. So this is my ECS registry. And for now, we just have one component type, which is rendered mesh, I think it is. ECS pointer, and in here, registry, please give me the type, is going to be ECS pointer. Now, this is what I want to copy somewhere else, right? This is the stuff that we're replacing now. We don't need to have this function here anymore. This is going to be added wherever we need to do, or wherever we need to kind of add the mesh. But I've just realized that we have a bunch of OpenGL stuff in here, because when we add a mesh, then we are also doing a bunch of OpenGL allocations here, because we obviously need to have like the buffer data, like the triangle data and stuff in the GPU somewhere, which means we have to call OpenGL stuff. So I am wondering now whether or not we actually have to move this, or if this can stay here. But we run this function every time we encounter a mesh that we don't currently own, right? Which so maybe we leave this here for now. So let's move this back. Right, we had the add function here somewhere. Add shader. Yeah, add mesh. I'm gonna have to undo some other stuff here. Yeah. Well, you can see that this is actually, you know, instead of adding it to the vector that we had, we are going to add to the registry now, right? So registry dot, I think it's called newest set or something. Let me just make sure. Yeah, so newest set, and then we just put the component in there. So the entity ID, we can generate a new one with registry dot new entity ID or something. Registry. The chat's gone a little bit quiet now, so I kind of feel bad that it's not very interactive. So how are you all doing? Maybe you can have other classes for the OpenGL buffers. Yeah, maybe we can. Maybe we can actually have a system class, right? So we can have a class that is somehow tying up all the OpenGL stuff with the ECS as well. So every time there is a new, oh, sorry about that, I just like literally kicked the table. Every time there's a new entity that has a mesh object, that class will be running this code here to actually add the stuff to OpenGL, as well as, you know, tying up the registry. But yeah, so I do wonder, do I have a ID somewhere? I thought I had a function called getNewID. Entity ID here. Would generate new ID. Generate entity ID, yeah. ECS generate entity ID. Let's see if that's available to us though. Yeah, there you go. So we add that, and then we also add the rendered mesh here. Now this should work. I'll explain what the benefits are of doing this after we actually get this working. Newest set is not a member of shared pointer. Yeah, it is not, because I am not using the pointer here. I'm also assuming that we have the registry valid, right? But we should really be putting the if the registry, or if not registry. We should probably return something. What are we returning in this? Nothing. So this is a void function. Like, yeah, we don't do any of this if we don't have a valid registry. Now, renderer.h, what do we have here? Okay, we can't actually open the include file. That's interesting, isn't it? Oh, is it because it's actually, yeah. We need to forward declare it. There you go. That's the thing. So now let's do a forward declaration here, right? Because we don't want to include this there. We would like to just add it up here somewhere. In that way, we are not actually exposing this dependency to the user of the renderer class, right? Just keeps things a little bit less messy. So for that, what we're going to do is we're going to forward declare that registry class. So namespace, ECS, I think it is. And we do have a template type name Cs, I think it is, and then we have a class called registry. That is it. Now this should compile, and then we should also have, yeah, we should probably, you know, we're going to run into a very common problem here in C++, and I'll explain to you guys how to solve that. So if you haven't been paying attention, this is a good time to pay attention, because you will for certain come across this issue at some point in your C++ career, especially when you're working with for declaration, right? So here it is. What have we done here? So I've removed the ECS include directive here from my renderer H file, because I quite honestly don't want to leak the third-party dependency headers through my renderer.h, right? It's just, you know, easier to not keep things messy, and it's better practice. So what I did is I forward declared my namespace MAECS, and I said that inside this namespace we have a class called registry, which takes a variadic, or a parameter pack, right? So basically just matching whatever we've got in the registry as well. So if I actually F12 this should be found for me, right? So basically matching that definition without anything else. That allows me to then use this class here, registry, in a unique pointer, or a shared pointer, or a raw pointer, right? Or a reference for that matter. You can do all these things here. Because at this point in time, C++ doesn't need to know the definition of the class. All it needs to know is that, you know, there exists a class called registry that takes a parameter pack or a template argument. So all I'm going to do is I'm going to have this pointer to reference that. But that means that you then have to, in your CPP file, actually include the definition of it, because you can't compile code if you don't know the definition. But this is called forward declaration here for you guys, by the way. So this is how you forward declare things in C++. So you don't necessarily want your users to know the definition of registry, but you want to use it in a class or a struct member here. You can have a pointer to it or a reference to it, right? But that means that in your CPP file, you must add the include there. Okay, so you must have that. Now, when you do that, things will fail. So when you try and compile that, you get an error in MSVC, something like renderer, no appropriate default constructor available, right? Why is that? In this case here, you can see that I only defined a constructor for my renderer class, right? However, C++ is automatically, the compiler is automatically generating a destructor for me here for me. A destructor automatically is generated here for me, right? Which means that it's being compiled wherever this class is included. That's when it's being compiled. And there's a problem, because you can't compile the destructor wherever the code or the header is being used, because the user doesn't know, as I said, it doesn't know the definition of rendered or registry here, which means you can't delete this object, you can't create it. How you solve this problem is simply by defining the destructor yourself, even if you don't need it, because we don't need it in this case. So renderer, and you actually define it, you declare the destructor on the header file, and you define it down here, right? And why does this work? Because the renderer destructor is actually being compiled somewhere where it knows the definition of the things it's trying to delete. In other words, the shared pointer registry here, right? So when I do a build now, we will get a different error. So I've heard this before, that for declarations are much better in the header than includes whenever possible, but never understood why. Yeah, this will be probably the reason why. So, okay, renderer, no appropriate default constructor. We're still getting that error. We're still getting that error. But the problem is why? Because we really shouldn't be. We do have rendered mesh, right? Yeah, we have rendered mesh there. Let's do a clean build just in case. But yeah, you must declare that destructor whenever, you know, somewhere it knows about the definition of whatever you're float forward declaring, basically. Maybe I didn't save it. Ah, okay, see? It wasn't saved before, that's why it's still complaining. Unable to write file. Oh no, it's just a lock file, that's fine. I don't suppose this is gonna compile. There you go. No appropriate default constructor. That is interesting though. Visualizer. And we have the ECS stuff there. Good luck and have fun. Thank you, Day Redemption. Yeah, this is where I'm wondering why. Because in theory, what I explained to you is what was happening. And I have no idea why this is now not working. So I wonder if it's because one of the files doesn't actually have a proper reference or a proper link here to renderer in CMake. Let's take a look at that. So what are we actually compiling here? We are compiling Qt abstractions. So renderer, no appropriate default constructor available. And it's failing on the unique pointer. So we have... Why is it failing on unique pointer though? This is an interesting one, isn't it? Because we have a shared pointer here, so I am really interested in knowing what the issue is in this case. And out of interest, does it get fixed if we just include the header here? So if we do include ECS, ECS.hpp, because this might be a red herring in this case. It might be a different issue somewhere else. We're about to find out. Now, unfortunately, this build is taking way too long. So this can't find the file. Okay. I mean, this is because of the CMake, right? So if we were to just do public here, for the sake of it, let's see what happens. GL abstractions. Yeah, so we still get that error, even with the appropriate destructor included there, which is weird, isn't it? Now that's a bummer. That is a bummer. And just to make sure, we have added the destructor here, right? Renderer. Yeah. And if I remove this, do we still get the same error? Currently in the gym. Hope you have a nice stream. See you around, mate. Much support from Germany. Thanks, Al. Thanks, dude. And it's, yeah, we need to catch up at some point, Al. Not spoken to you in ages, dude. And yeah, have a nice evening, dude. Nice gym sesh. Be on that. I've already been to the gym today, so I'm already tired from it. Yeah, so we're still getting no appropriate default constructor available. Ah, what am I talking about, guys? I've been looking at this error for like 5 minutes, and the problem is that the error actually says that there's no appropriate default constructor available, which is right. There is no constructor available for us there. I was reading this as a destructor available, so that was still fine, right? So somewhere in the code we're using the renderer constructor, default constructor, that is. So we're gonna have to change that, which means that this code was actually fine. Let's move that back to private. And we do have the renderer being used somewhere. Let's find them out. So I'm going to say it's in a CPP file somewhere. There you go, unique pointer. So this is where we create one. This is where we create another one. Oh, they're both the same. And that is the only place where we actually create. And that's why it was failing on the unique pointer, because, yeah, you get me. Now we should pass in the pointer to the registry here, right? Because this is actually owned by a triangle window. But that means that we have to add. Ooh, this is gonna get ugly soon. Where is this code? This is in my audio visualizer. Interesting. So this is also gonna have to have a private dependency to what is it called? ECS here. Let's just kind of sort everything. Ooh. So all of those. Reconfigure it. Go back to where we were before. And then just cascade down the dependency, right? So in here we are unfortunately going to have to add a triangle window that will take a stud or shared pointer to a ECS registry of rendered mesh. Which means we might have to add a renderer here, or do we already have that? No, we already have that. And that can be a const reference because we're going to copy this anyway. And as I said, we also have to add the triangle window destructor here, which will both be coming from earlier on. Now, can I copy this stuff from my renderer? Because I will have to. Just a forward declaration. Where do I put it? I'm going to put it down here. And in fact, you know, if you guys are working with Qt quite a lot, there'll be a bunch of things that you need to forward declare sometimes. So Qt begin and Qt end, for example, are two of the macros that you might see around. And those are just used for forward declarations. And you can kind of see those quite a lot if you work with Qt, actually. So next time you see it, you know how it's used and why it's been used. So, right, this should have been window here. Triangle window, okay. Oh, we are in the CPP file. Oh, this is the main file. Never mind. Yeah. We don't have to forward declare things here, do we? No. Yeah, we don't have to forward declare things here because we already have the registry in this case. And this is where we're going to put our registry stuff here. So include ECS. Okay, that sounds good. Yeah, since we're not forward declaring it, we just need this, to be honest. And this is actually just used to forward declare the renderer, I believe. Renderer and renderer. God, I hate the underscore naming thing. I much prefer underscores. What do you guys prefer, by the way? So type in the chat. So do you guys prefer member variables that are kind of like this? So my whatever renderer. Or would you prefer something like, you know, just a renderer name? Or what I prefer, for example, is having the underscore renderer. You know, out of these two naming conventions, out of these three naming conventions, I prefer this one here. Just because I can straight away see that it's, you know, it's a local member of a class or a private member of a class. And it only takes one extra character to do that. Now, I've seen people actually putting the type of things as well. So like M renderer string, that I extremely disagree with. I think, you know, you have a language like C++ where you have the type of the thing right in front of you. You don't have to put types in names. But yeah, you prefer underscore as well, Robin. Yeah, you're my man, dude. That's why we're friends. That's why we're friends. That's what I can say. But yeah, it does annoy me when people, like, specifically when people put types in the names of variables. Like, I'm always like, why? Like this one here, m vertex array, vertex buffer. I mean, in this case, you know, it kind of signifies a vertex array ID, which is fine. This is not code written by me, by the way. This is I think I've just copied and pasted this from the Qt website at some point, so that's why I'm complaining. But yeah, that's it. So mRenderer is gonna have to be a stud. Is this a unique? Is this a unique pointer? It is. So a stud make unique of renderer, and then we're gonna pass that ECS pointer there. Now, is this going to work a little bit better? Let's see. It's compiling more things, but it's still no appropriate private. No appropriate constructor. So there is somewhere we're using a stud unique pointer with renderer, which is here. Like, I don't see why. Make unique renderer. Okay, yeah, we are using that in there as well. So where am I calling this function? Initialize. This should definitely be done on the constructor as well, right? It's just so we can use RA and Y. Y Qt. Y. So yeah, Qt code seems to be acquiring a bunch of resources on this initialize function. But my point is that you can probably just do all of this. I've added on to this stuff as well. Whatever we call the constructor, that's what we're supposed to be doing anyway. But yeah, I mean, this is the second place we have to add a shed pointer just to get things compiling to ECS registry of rendered mesh here. Okay. Yeah. And now it should compile, I believe. Let's see. God, I've been drinking this drink, guys. It's a blue raspberry fizzy drink, and it tastes like your childhood. You know what I mean? Not necessarily good, but sweet as hell. And the thing is, it doesn't even have any sugar in it, so I can still sleep basically. But I'm scared of the amount of aspartame that I'm putting into my body right now. If you want to try it out, this is the one. Slush puppy. It still didn't compile. Let's see why. So void anonymous space triangle window initialize. Yeah, now that's my bad. Illegal reference to non-static anonymous namespace mrender. What? mRenderer. I don't see why this is not working though. Yeah. Oh yeah, it's because I forgot to actually change the definition here. This is rendered mesh right here. Do a quick build. There will be somewhere where I call initialize as well. In this case, initialize. And where is that going to be? Yeah. Where is that going to be? Okay, now it's just my calling code, I believe, right? Or no. Anonymous namespace, triangle window, initialize method with override specifier, override. Did not override any class. Yeah, that's correct. That is because we have it here, right? So we should be putting, where is this though? Do I add another reference to my ECS here? I'm gonna have to for now, right? So let's do this. Private ECS. Now in here, I'm gonna have to add that forward declaration as well. Unfortunately, there you go. Forward declaration with Qt. With Qt, sometimes you have to forward declare things to kind of not cascade down dependencies, and this is how you do it in there. So if you look at Qt namespace begin, it doesn't do anything. Oh, interesting. But yeah, that's why you can see all this code in their examples. Okay, so we are gonna have to do a namespace ECS. We have a class registry, that's it, and our initialized class here is going to be taking a shared pointer to our ECS registry. That won't do anything. So rendered mesh is obviously not here. We are probably going to have to add a reference to GL abstractions, wherever that is for now, because we need that rendered mesh so we can use it as a template argument. Now the problem is that this is probably going to cause a circular dependency, because I'm not sure if my GL abstractions target here depends on the Qt abstractions. Does it? No, it doesn't seem to. So we might be okay. But yeah, this is the one we need. So GL abstractions. I'm going to add that in here, right? So in the public one as well. Which means that we should be able to include GL abstractions here and renderer, I believe. Right? Yeah, there you go. And the same thing is going to have to be done on the header file, because I also need that type in here. Let's add it just here, shall we? Now, that override message should disappear. I could also just remove the override there, but I kind of feel like I'm going to expand this OpenGL window stuff a little bit more later on. So our OpenGL window initialize does not take 0 parameters. It doesn't really. Render now. So where are we? So we are, yeah, so we are actually going to have to store the shared pointer in here. Shared pointer to ECS registry. So we have an explicit one here. We're no longer in the explicit anymore because we have the shared pointer coming in. So this is going to be a stud shared pointer to, I've been writing this for so long now. So, and I still get it wrong every time. Registry of renderer. Giving rendered mesh. Okay. Now, I should probably change that one here as well. There's a registry of rendered mesh. And that should work now, right? Hopefully. Oh, exactly. Except we haven't actually got the necessary headers for the ECS thing in here. So we should have a, yeah, we should have a ECS.hpp here. I'm wondering if I should do something else with you guys. If you want to look into anything in particular, let me know. I know that this is, you know, it gets quite boring when I'm actually doing work, which, yeah, it's nothing I can do really. Sometimes I want to do some code on the stream, and that means I have to focus. But I'm still listening. I'm still here, seeing the messages, still here to answer questions. So, so this does not take 0. That's correct. That should be the registry. Now we're basically just chasing that compilation again. I prefer mrenderer. Hello, Murderface. I think it might be a tad delayed, my dude. You might be a little bit delayed. Right, first error, OpenGL, no appropriate default constructor. Yeah, so we must call, this is the interesting stuff, OpenGL window now with the ECS pointer. That will solve one of them. Anonymous, triangle window, no appropriate default constructor. That's correct. That's because we need a registry here. And this is where we actually create the ECS, right? So this is where we do ECS registry of rendered mesh registry. Oh, in fact, it has to be a shared pointer, right? Because we set it that way. Shared pointer registry is going to be std make shared I think that's it. Obviously, it won't compile. There'll be something else, and we'll be on this for like another 10 minutes or so. Right, this is where it gets interesting because I have linking error now. So error, generate entity ID is already defined in this. So generate entity ID is being defined twice, but why? Why though? Ah, yes, because this is not a templated thing, so it is actually being defined every time we compile the code. No, well, we can do a static inline, right? That will get rid of it, hopefully. Yeah, but why was that defined twice? That's an interesting one. Because it does it defy the one definition rule in this case when you have definitions in the header? Well, interesting anyway. But we have successfully converted, hopefully successfully converted, the application to use the ECS to keep track of the meshes. And of course, as you can see here, we have a no pointer dereference or something like that. So let's just ignore this and see where we're actually getting the no pointer dereference here. The initialize OpenGL functions is the one. The OpenGL window. Let's see this. So it is definitely in the make unique renderer here, which is calling initialize OpenGL functions. And what is that actually doing? That's just Qt code, right? To be honest, I've never seen this error before. I'm interested in knowing what is going on here. So this is when we do it. This is what happens here. I mean, this particular line throws the error, right? So there's something funny going on here. My registry does make sense though. There is a pointer here, and I do have component values and whatnot. Yeah, so what the hell is going on? So Qt OpenGL functions 4.2 is like an initialization of Qt itself. So tget from read access violation scope pointer. Yeah, I mean this is a no pointer dereference, so something is no pointer. I can see it here. There's an offset 8, which is very close to 0. I mean, you'd know more about this if you work at CrowdStrike. Obviously, this is the kind of stuff that they do, right? The best, and I've just done that myself as well. And you can see why that happens. By the way, you can see why people like CrowdStrike cause so much havoc with no pointer dereferences, because it's very easy to do them in C++, right? Very, very easy. So one of these things is null. This is not null. ECS pointer is not null. So OpenGL window. What is that doing? So we are setting the registry. We are setting the parent as, I think this is no by default. So it could it be that? No, it can't possibly be this, because this was being set to no in the first place, right? So maybe something to do with initialize here. If m device, create a new device. And in this case, we don't do anything with the initialize function because we definitely changed this one. Huh. Is there an initialize function in here? That's the question. So we have initialize OpenGL functions there. So something is not getting initialized. I'm going to put a little breakpoint here. I want to see if this constructor is getting called in the first place. So I'm not entirely sure now. And it does, yeah. It does get called. With valid pointers as well. Valid pointers as well. No parent, hopefully. Yeah. But then when I make a renderer, this is what fails. This particular line here. Let's see if we can figure out what is null in this case. So context is null. Ah, okay. So current context is null. And where does this context variable come from? Like, where do we actually set this? Where does Qt set this? This is Qt code again. So do I need to call initialize before? That's the question. No, there is no initialize here. That is interesting. Is there another initialize function in here? Initialize OpenGL functions, context. Some of them look promising, but I don't know what to do in this case. I think we just have to initialize or pass in a context to this. Let's take a look at the Qt documentation, shall we? So this is the function that we're calling here to initialize the OpenGL functions, and it basically just sets the, as far as I know, it sets the OpenGL function pointers in the same way that something like glue or glad would do, right? So they look for the functions in your system and initialize the function pointers. That's what this does. But this clearly needs, or it's clearly breaking because we've made a minimal change. We added a pointer to the class. So I'm wondering, why is this not working? Ah, yes, it's not working, and this is why. Should we call OpenGL functions call? Like, first of all, what did we need? Yeah. I mean, I'm pretty sure C++ does this automatically, right? But should this be called first before we initialize the pointer there? Because I'm not too sure in which order this gets called in. But I don't think it's going to make any difference, to be honest. This is done automatically in C++. Yeah. Interesting. Let's keep reading the documentation and see if we can get this code to actually show things today. initializes OpenGL function resolution for the current context. After calling this function, the OpenGL functions can only be used with the current context and other contexts that share with it. Call initialize OpenGL functions again to change the object's context association. So maybe, just maybe, we don't have a current context set because we also made changes to the triangle window, which is an OpenGL function here, right? And I wonder if it's because we haven't initialized the stuff here. Public and protected. So if I do something like the OpenGL functions call here. Actually, I want to put the registry at the very end of this. Yeah, I can never remember what the rules for constructor, virtual constructors, or inheritance constructors are for C++, to be honest. I know automatically it calls the default ones if you don't specify it, or it should be anyway. But I don't know what happens when you have like multiple ones. Does it, if I define or if I call the constructor for key window, is it going to do the same for Q OpenGL functions? I think it does. You know, in theory it should, but registry is not a base. Huh? What the hell? So does it have to be here at the front? Interesting. That's good to know. I mean, if that comes up in an interview now, I will know. So registry is still not a base. Oh yeah. Let me spell it. Registry. There you go. This is where having someone who works with Qt would be much appreciated here. Nope, still didn't work. Why? Why the hell is this happening? I keep forgetting that opening terminals for debugging here on VS Code doesn't actually close them, which is a shame. But what I wanted to do is, like, if we can't figure this out, let's see if we can figure it out from the changes that we've made. It's not in this repository, of course. It's going to be here. So in particular, we have made changes to QL window, GL window, that is, sorry. So git diff. And this is something I always do, by the way, guys. Like, if I have no idea what I've broken, I will look for the changes until I can spot something. I'll be like, ah, yes, this is what caused it. But in this case, I don't really see it, you see. So I removed the Q parent, the parent here. I added this constructor instead, which just sets the registry and calls that function. We've just added brackets here. That shouldn't break anything. And we initialize. Okay, maybe this is the call here. Is that a virtual function is going to be? No, it can't be, right? that initialize function is not. So initialize the logger. Yeah, I'm wondering if any of these functions have an initialize call to it, because maybe OpenGL does. And should I be calling it? No, this is the only initialize function we have. What about key window? Is that something called initialize as well in here? Also no. So it can't be that. Well, too bad. Let's move on to the C file. So what have we changed here? The constructor again. Yeah, I mean this was the C file. I guess the header file we won't see too much either. Except we've added the renderer, include slightly modified the initialize function. Okay. I don't think any of this will have broken anything. So let's move on to another file. The one that could have broken things is, I guess, whoever's using this class. And we can see it in the code. I think it's in main somewhere, right? Or the triangle window. Yeah, so main could possibly have broken things. Maybe we look at main right now. So what did we change here? Nothing really at the moment. Yeah. Yeah, this is all the audio stuff that doesn't matter to us. Yeah, I'm gonna be honest, I don't know. I really don't know. Triangle window, what does it call initialize? Because that is a function that we did change, and I'm wondering if it was meant to be calling the parent class's initialize function, but not too sure now. This is definitely not working for us. Maybe we'll find something on the... There you go. It is assumed that OpenGL context associated with the function resolver is current. Maybe we can look at the OpenGL. With Qt6, right? So the OpenGL context class renders on a Q surface. And we definitely don't have any references to context, right? What is it called? Q OpenGL context class. No, that is not a thing. We haven't mentioned that in anywhere in the code. But we have mentioned GL Paint device for sure. Right? Yeah, there you go. So maybe this thing here isn't actually being created, which is in the OpenGL window. Where is this getting referenced? Oh no, don't want to rename it. Just want to find where all of you are. It's in here. right? So if we don't have a device, we create a new one. We set the stuff and we call render. And this has not been called anywhere, is it? Not before the crash anyway. Yeah, it's not. So we don't actually have a valid render pointer. I do wonder what happens if we move the new OpenGL thing in here, right? So set surface type. What if we do this as well? That is my question. What if we just create an OpenGL surface? Does it work now? And this better not fail now because I literally just copied and pasted some code. See, we create one of those now, but we still fail to get a current context. Static assert. Smart pointers for Q declare must have no except get. What? What is this even doing? Terminal. Assert context in file for line 199. What? I actually don't know what we're even looking at. Yeah, so D is definitely no. And this is all because context here is null as well. Let's just rerun this and see. See, this is going to be null for sure. Yep. I'm lost. This is weird. Yeah, I'm lost as well. So basically, we've let me try and summarize the problem here. We've literally just removed an array that was keeping track of all the meshes that we create, and we moved it to the ECS, right? So we did that, and it compiled. Now, in doing so, we also had to pass down a pointer to the ECS down to the renderer because the renderer needs access to it, which means that I also had to pass a pointer down to the queue window, or my abstraction of the queue window object, which is here. Somehow, that made it so the OpenGL context is not being created. And in fact, this is null. So whenever it comes to getting the context, somehow we get that the object for the context is null. So I'm trying to figure out like what caused it, because quite honestly, I have no idea. And this is definitely weird, and I'm also kind of lost, but I'm trying to keep the strings of my brain stuck together. Hi, have you written in Golang logger, zerolog, and tracer at work? What do you think about it, and is it necessary? Hello, Chichumba. Yeah, a little bit of a break for now, I guess. Let's talk about Golang. Yes, I've written zerolog, and I like it. Do I find it necessary? Yeah, I mean, logging is good. Having logging, different logging levels, for example, for an application is definitely a good thing to have. I have not used the second one you mentioned, though, tracer. I have not used the tracer in Golang applications. But, tracers are good as well. They add stuff to debug code quite easily. And if it's done properly, when you compile the code, those tracing things should disappear, right? That's what tracing does. Especially, the C++ ones where you can hide code in between debug and release. But yeah, I mean, I don't really have an opinion. Logging is good. I like logging. Tracing is good if you have like, if you can't access a debugger, tracing is the next best thing. So why not? Or debug logs for that matter. But anyway, like, why the hell? Why the hell is this not working? So Qt application, QSurface format, set samples. I set the format of my window here. That has nothing to do, I guess, with the problem at hand. OpenGL window is being initialized. Now let's look at the documentation for this one here. OpenGL window. So, detailed description. OpenGL window is an enhanced Q window that allows easily creating windows that perform OpenGL rendering using an API that is compatible with OpenGL widget. Unlike OpenGL widget, OpenGL window has no dependency on the widgets module and offers better performance. That's nice. A typical application will subclass OpenGL window and re-implement the following virtual functions. So we have initialize GL to perform OpenGL resource initialization, resize GL, I guess to resize windows, and paint GL. Now we've not actually re-implemented any of these, right? Have we? Let's take a look. So public OpenGL window. Yeah, we've not done any of that. Schedule repaint call, the update function. Know that this will not immediately result in a call to paint GL. Okay, I mean the rest of it is kind of, I'm just trying to figure out the context here. So can I search for the word context? Right. The OpenGL window, there are two constructors. This is the default one, which calls open. See, but that's the thing. We're not actually using this. We are using our own implementation of an OpenGL window. So this is not a Qt thing. This is our own OpenGL window. I wonder if we can just use this one instead, but yeah, I mean this code was copied from, many moons ago from one of the Qt tutorials. I'm not sure if it's still valid anymore. But either way, this should, this was working yesterday and it's not now, so let's see. I'm still gonna try and debug this. See, OpenGL context. This I expect to be something. Oh wait, yeah, paint device. We haven't actually defined the context. Let's see what that's getting used. So find all references. There you go. So this is not running. So render now is probably not running, right? So we set format to the surface. What happens if I just call a render now? I'm pretty sure that this was in. What if I just call render now in here? Because that will force it to kind of create a context, right? So I wonder if it's going to work. Because obviously this context creation stuff has to be called. Oh, why did it not work? Are we still debugging something? Yeah, we are debugging something. There you go. Let's try and build it again. Because clearly this context creation has to happen before the triangle stuff tries to draw anything. And somehow that before was working, but is it going to work again? That's the point. No, this works. Render now works. Tell me that the context is not null. It's still null, so it's still going to fail here. This is very annoying, guys. Very, very annoying. You OpenGL context. So clearly, context is not being created anymore. I have no idea why. And this is literally the only place I can see where the context could be created. You OpenGL context of this. Oh, wait a second. Wait a goddamn second. Q window is the parent. So how was the triangle stuff being defined before? Did I have a constructor by any chance here? Don't think I did I? I added this one myself. OpenGL window, OpenGL window. One more try. Maybe if I pass the OpenGL window pointer as the see renderer here. Does this normally have a function that takes in the context pointer? Because I think it should, right? Let's see. No, it doesn't. It doesn't actually have that. Huh. I still don't know why this returns like in no context. Because it definitely is creating the context and then setting it. Right here. So Q OpenGL current context. This is a static here. R sharing. Make current. What does make current do? At some point our program does call make current, so I need to figure out like why. No, it doesn't. It doesn't call make current at all. I hate these terminal windows that never close themselves on Windows. For a debugging session. Yeah, so render now. We don't have is exposed. I see. Yeah, so this wasn't running in the first place. That's fine. I do wonder what happens if I put this in there though. Like it should be. It should be here in the first place. I don't see why it's just in the initialize. Oh no, this is also not supposed to be right here. This is supposed to be right here. Set surface type. Set format. Right, now we know for sure that the context will be created, or we'll try to create it, right? Okay, so something happened. This is still no, so it's still gonna fail. Ah, I'm kind of giving up here. Let's try another 10 minutes. If we can't fix it, we can't fix it today. I'll have to go away and do it myself. But that is painful though. That is very painful indeed. Because we for sure create a context here. Do OpenGL context. Close everything and just leave the code that I actually want to see up here. So I don't get distracted. Wait, what? Reload window. I swear VS Code just like randomly stops working in debugging as well. Like I just pressed that button and obviously it didn't work. I don't know why. It loses track of see file name there cannot be resolved. Like why do I care about that? Do I have to have at least one file open to run it because I mentioned the file there? Yeah, I have to have at least one file open. Interesting. That's a nice little bug for us, isn't it? Yeah, so this is the interesting bit. So this gets called, and it does create an OpenGL context. mContext set to current. Do we have the set to current? No. Ah, we also want this here. Okay, so we also want this set current. Let's remove render now. It doesn't make sense anymore. So maybe we are missing just the make current. It still doesn't explain why it was working before and now it's not. Like the same things are getting called. So make the current is valid. Yeah. See, now we actually hit this breakpoint that we thought we would hit. Initialize stuff. It's still no. Oh. This is painful as hell. This is really painful. Let me just see one more thing though. So current context. We have a breakpoint in here somewhere, right? Yeah, we have a breakpoint in here. Current context. So this definitely returns a null pointer. And right now we are here where we say make the current surface the context, right? And we have something that makes sense here. So this. So OpenGL window is a surface from the looks of it, right? It is a Q window, which inherits from what? Q object and Q surface, yeah, so it is a surface, of course. And we do have a surface, and we have a surface. Oh, right. So we don't have a surface handle. What does that do? Right, we need to look at that because I have no idea. So that's what we're missing as well. Surface handle is false, and somehow we need to turn that value to true. Q surface. Surface handle returns a handle to the platform specific implementation of the surface. So this kind of implies that we don't have a handle to the or Windows specific, like window, shall we say. But how is this created? That is the question. We set a surface type, we create the context here and make it current. But maybe we should call initialize. Render now seems to do something. Initialize OpenGL function, initialize registry. What if I just actually call the render now in here? And does this somehow call something that creates me the surface? I kind of believe it probably does. But we shall see that. So we go in here, we create surface, why not? Okay, initializing. Okay, we make the current. We need the logger, that's fine. I don't care, don't give a damn about that. Don't give a damn about that. Oh, but yeah, we reached the same problem basically, where we don't have a surface. That is annoying, guys. I'm not gonna lie, that is very annoying. And to be honest, I'll need to find out what I've done here, like at which point it broke. Because, you know, when you have no idea what you've broke, then it just means that you have to bisect all the changes you've made, do them step by step, and then figure out, all right, this is at this point, this particular change here, this line broke here, and this is the only way I'm going to solve this. And you know, if I was to do this on the stream, it would be very boring for you guys. But I'll tell you what, thank you all for watching today. It's been good. I think, you know, at the end of the day, we did manage to. Hello, Al. You came back just as I'm about to leave, man. We were kind of stuck in an OpenGL bug where we don't have like a surface or a context, and it's trying to initialize some OpenGL functions, and somehow I've broken that entire kind of model. It's like it was creating a context before, and now it's not. So, but I need to figure out how I've broken it. But yeah, thank you all very much for watching this. It has been productive nonetheless, though. We did manage to include the ECS here. And I believe the ECS actually works. Once we get rid of this issue, we should be able to see the you know, the cube drawing again through the ECS this time. So all the mesh data is going to be on the ECS. But with that said, you know, I'm going to have to leave here, guys, because I'm getting quite tired and I need to go. I need to work tomorrow. But you know, I will try and do a stream maybe Saturday, Sunday. Sunday's actually, well, Monday next week is my birthday, so I might not be available on Sunday. But I'll try anyway. And yeah, I mean, stay tuned. I'm gonna release a video on smart pointers this week. It's already recorded. I'm just editing it, so stay tuned for that. If you do see it, please like the video. Otherwise, thank you all very much, and you know, have a good evening. Bye bye. I'm gonna drop it here.